Okay, so this is a word problem for systems of linear equations in 3 variables. So when I read these word problems, I always try to find at least 3 different things that I am going to be relating to each other. So the first things, I just try to find those 3 and label them, I guess, X, Y, Z, generically. So when I'm reading this, it's a theater charges $50 per ticket for seats in section A, $30 per ticket for seats in section B, and $20 per ticket for seats in section C. So I've already found 3 things that I'm going to be relating to in this word problem. So for my let statement, I will let's just do A. So let A equal, I guess, number of seats in section A, B equal the number of seats in section B, and C equal the number of seats in section C. Okay, so now I've found those 3 items. Now I need to look at the sentences and see if I can create 3 separate equations relating those guys to each other. Okay, so not really much there. For this one. For one play, 400 tickets were sold. Okay, I know, so that the total number of tickets sold was 400. So this is the number of tickets sold altogether. So the number of tickets A, number of B, number of C. So I can create my first equation. Number of tickets for section A plus number for section B plus number for section C should equal 400. Or sorry, I meant to say 4,000. Okay, it's supposed to be 4,000. Okay, now after that, let's find something else to create another equation. So, okay, so they were sold for a total of $12,000. So I know that tickets from section A are sold for $50 per ticket. So if I sold 1 ticket from section A, I'd make $50. Okay, so the total number of tickets from A times 50 for the dollars plus B, and B was $30 per ticket. So 30B plus $20 times the amount from section C should all equal $120,000 in revenue. Okay, good. So we have 3 equations. We need 1 more. Let's read on. If 1,000 more tickets in section B were sold than the other 2 sections combined, how many tickets in each section were sold? Okay, so I know that if 100 more tickets in section B were sold than the other 2 sections combined, so I know this. Another way to say this is that section B is 1,000 more than C and A. I can rewrite that. So section B is 1,000 more than C and A. Okay, so now I have my 3 equations for my 3x3 system. Now I need to solve. Well, I'm going to rewrite this a bit so that it's more in standard form. Okay, so let's see, just go alphabetical. A plus B plus C equals 4,000. I can divide these all by 10. Let's just do that, simple. So 5A plus 30B plus 2C equals, dividing that by 10, I get 1, 2, 1, 2, 3, okay, 12,000. And keeping the B on this side, subtracting, oh, that should be a plus there, I'm sorry. Okay, subtracting C and A, so minus A plus the B minus the C equals 1,000. Okay, yeah, that should have been a plus A, sorry about that. Okay. So now I have everything set up nicely, and I am going to pair off my equations for step 1 in solving. So step 1, pair off. And I'm going to choose the variable I want to cancel. Let's just choose C, since C's got the lowest number here, and just 1's right there. So pair off and cancel the C's. Okay. So I'm pairing the first equation with the second equation. So 5A plus 3B plus 2C equals 12,000. And then the other one, the first one, plus B plus C equals 4,000. And now I'm going to pair off the first one and the third one, sorry. A plus B plus C equals 4,000 minus A plus B minus C equals 1,000. Awesome. Okay, so let's cancel the C's. In our second group, we can just add, and we'll end up canceling the C's. And look, the A's happen to cancel out as well. So A plus negative A, that's 0. B plus B, so 2B. C plus minus C, those cancel out. And this equals 4,000 plus 1,000, 5,000. So dividing both sides by 2, I get B equals 25,000. Or 2,500. Good, I already found one value. Awesome. Okay, so now I'm going to solve the other equation. Let's see. Since I want to cancel the C's, I need to make this C have a 2 as well. So let's multiply this whole equation by 2. And I can rewrite this as 5A plus 3B plus 2C equals 12,000. And then I get multiplying this all by 2. 2A plus 2B plus 2C equals 8,000. Okay, now since these are both addition, I will subtract these equations to cancel out the C's. So 5A minus 2A, 3A, 3B minus 2B, plus B, 2C minus 2C, awesome, gone. That equals 12,000 minus 8,000, so 4,000. And that is my next new equation. Okay, so step 2 of our plan is pair the new equations and find, in our case, A and B, even though we have already found B. Okay. So my new system is 3A plus B equals 4,000 and B equals 2,500. Well, since I have B already solved, I'm going to use substitution. So 3A plus my B value, 2,500 equals 4,000. And I get 3A equals 1,500. Dividing by 3, get A equals 500. Great, so now I have solved for A and B. My next step is to get to C. So step 3, find C. So I will go back to one of my original equations, just the simplest one, and solve for C. Let's just pick the first one. That looks pretty good. So A plus B plus C equals 4,000. I could have picked any one of these equations to solve for C, but I tend to like to pick the simplest one. Okay, so my A value is 500, plus my B value, which is 2,500, plus C equals 4,000. Okay, adding that up, I get 3,000 plus C equals 4,000. Subtracting 3,000 from both sides, I get C equals 1,000. So my let statement, we were talking about the number of seats sold in the sections. So the question we had was, how many tickets in each section were sold? So my final answer, written in a sentence, would be maybe, let's see. So 500 tickets were sold in section A. 2,500 tickets were sold in, what was that from, B, and 1,000 tickets were sold in section C. Okay, so 5,000 tickets were sold in section A, 2,500 tickets were sold in, that should be section B, and 1,000 tickets were sold in section C. So that's what we did. So first thing we did was read the paragraph, identify the three objects we're going to be relating to each other. So we found those. And then look through the sentences to find different ways you're going to be relating them to each other. Create three equations from those. Solve by pairing off and canceling one variable. You want to just cancel one variable. So don't be canceling x's from here or y's from here. Just pick one variable to cancel. Step 2, solve this like a normal 2x2 system. Step 3, find the other variable that you had canceled originally in step 1. And write your answer as a nice complete sentence.